Alright, so this is lesson 8B, and our learning targets for today are these four. So at the end of this lesson, you should be able to explain in your own words the meaning of factorial. You should be able to evaluate factorials. You should also be able to write products in terms of factorials. And finally, we're going to study my favorite mathematician, Blaise Pascal, and his famous Pascal's triangle. We're going to interpret and write its notation as it relates to factorials, and we're going to be finding values on his triangle using that notation. So let's go ahead and get started. And just as a reminder, these learning targets need to be written down in your notes. If they're not written in your notes, you don't get points for your screencast notes, so make sure they're there. If you need to pause at any time, go ahead and do that. All right, so a factorial looks something like this. It's a number or a variable followed by, okay, if I wasn't writing in black, that would be helpful. It's a number or a variable followed by a question mark. So the British call this a factorial, but they might also say 8 shriek, right? Because you shriek with an exclamation point. I don't know, I think it's kind of funny. So 8 factorial is actually equal to this. We start with the number here, and a factorial means to find the product of every number below it and stopping at number 1. So the product of 8 factorial would be all of these numbers multiplied together. Okay? So the product of 3 factorial would be equivalent to 3 times 2 times 1, which is 6. Okay? The product of 5 factorial is equal to 5 times 4 times 3 times 2 times 1, okay, which is 120. So what you should notice is that the smaller your number in front of your factorial, the smaller your outcome. The larger the number in front of your factorial, or part of your factorial, the larger the outcome. So 8 factorial is going to be even larger than 120 because we'd also be multiplying 6, 7, and 8 by these numbers. So the technical math definition looks something like this. So if we replace this number with a variable like n, and we call it n factorial, what this means is we start with the n term. Okay, so we say n times, well, we started with 8 here. And what is 7's relationship to 8? It's 1 less. So we take our number and we take away 1 and multiply it by n. Then we take away another 1. Okay? So now we're to 6. So this becomes n minus what makes 6? 8 minus 2 makes 6. So this becomes n minus 2. Then from 8 to 5, that's n minus 3. From 8 to 4, that's n minus 4. And this goes on infinitely, okay, until you reach the number 1. Look, I dropped number 2 here. That was very bad of me. All right, so this is the technical definition of a factorial where n is your starting number. All right, so let's go ahead and I want you to practice, okay? So I would like you to find 4 factorial. So evaluate. So what you should have written is 4 times 3 times 2 times 1, and this equals 24. Okay, so 4 factorial equals 24. This is just the shorthand, so we don't have to write all of these numbers, especially useful when you have large numbers. If I'm going to find 19 factorial, we know this is going to be a really large number. Put it in your calculator. There's a button on your calculator that has an exclamation point. So find it and say 19 factorial, and I'll show you how to do that in class. All right, what happens if we have something that looks like 3 factorial times 2 factorial? Does this equal 6 factorial? So let's check. So we end up with 3 times 2 times 1, okay, times 2 times 1, okay? And 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1. All right, so we end up with 6 times 2, which is 12. This number I'm looking at is way bigger than 12. So can we do this? Can we say 6 factorial times 2 factorial equals 6 factorial? The answer is absolutely not. They do not, you can't multiply like this. You have to do each one individually. Likewise, if you have something that looks like, we'll say 4 factorial divided by 2 factorial, does this equal 2 factorial? So let's go ahead and write it out. We have 4 times 3 times 2 times 1. We also have 2 times 1. Well, what we notice here is that 1 divided by 1 is 1, so that becomes a 1. 2 divided by 2 is 2, so we end up with 12. So this is 12, and 2 factorial is 2 times 1. Do these equal each other? They don't, okay? So we can't do that. So the lesson here is that whenever you have factorials that are multiplied together or divided, you can't do the division or the multiplication first. You have to do the factorial first. So let's go ahead and we're going to practice writing factorials now, and this is the last thing we're going to do. So what happens if I give you something that looks like this? Okay, well, we know it's a factorial because it goes down by 1 each time, right? Okay, but it stops. We're missing times 3 times 2 times 1. These aren't here. So when we write our factorial, we start with 8 factorial, and we have to divide it by something that would represent this. Well, 3 times 2 times 1 is a factorial itself. It's 3 factorial. Okay? So anytime we stop short of 1, we always write this as a division problem. So let's try this one. Alright, so you might notice that this order is ascending rather than descending. So if we wanted to do it like this, we could. It works the same way. So this would be equal to, well, we're starting with 14 times 13 times 12 times 11, and then we're stopping. So we can say it's 14 factorial divided by something. Well, the number that we're going to start with that comes next would be 10 times 9 and dot, 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 so on. But these aren't accounted for. So since I'm starting with 10, that's the first number in my factorial in the denominator, and all of those are going to cancel out. Okay, you might be wondering, why does this work? Well, let's look at 6 factorial divided by 4 factorial, and I'll show you why it works. Okay, so 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. Now, maybe you figured out what's going to happen now. Hopefully so. Well, 4 factorial is 4 times 3 times 2 times 1. What happens is 4 divided by 4 is 1. 3 divided by 3 is 1. 2 divided by 2 is 1. And 1 divided by 1 is 1. So we end up with a value of 30. Right? So what happens is when we divide by 4 factorial, what this is basically saying is we multiply the first two numbers of our 6 factorial, 6 and 5, together, and then every number after that through 1 makes 1. It divides itself out. So we're only multiplying these two together. So that's what's happening. Let's look at one more that's a little more abstract. How would we do something that looks like this? N times n minus 1 times n minus 2 times n minus 3. Well, hopefully you remember from our definition that this is n factorial, because the definition of a factorial is it starts with n, then we take n and we take away 1, and we multiply that by n minus 2, and so on.